our topic of today's discussion is how do you use Selector AI to have enhanced observability into your network. Before I start, let me introduce myself. I lead the solutions team at Selector. I've been at Selector close to more than 3 years now and led multiple different roles. Prior to that, I was at AWS and at Juniper with Nitin and other co-founder Kanan. So today I will primarily do the introduction, introduce you to the product and what are the customer deployments we already have. And before I talk about the specifics of the product, how do we solve the problem? Let me highlight some of the key challenges that we saw over our experience and also talking to customers. The first thing that we noticed is that whenever network operators or just the operations team looking at any kind of outages or looking at any kind of issues, they have to look at multiple different kinds of sources of data to figure out what's happening. Yes, metrics is one of the key things that they look at, but contextual information, for that they look at configuration events, alerts, logs. Logs has a lot of good information which they go and browse and look at that. But what happens is that when they're looking at these different data sources, they're looking at them in silos because there are multiple monitoring tools in the market. You can just look at metrics, just look at logs, look at events, and they look at this multitude of dashboards and try to do some kind of manual analysis. Over the years of experience, they got those insights and they try to look for those signals in different dashboards and then figure out, okay, what's happening. But then once they get to that point, they have to communicate that to different teams. That could be application team, that could be a networking team, that could be an operation team. Everyone needs to know what's happening. After that, they decide on a fix and run the playbook. So in this overall process of getting the data, doing manual analysis, and sharing it with the teams, that takes the most amount of time during an outage. Fixes are usually they would have some kind of a playbook. They'll go do a restart or a reset or some kind of action to get the services back. But majority of the time is spent in this upfront work of analyzing the data. So what we do is that we can collect heterogeneous data, like all different sources of data listed here, not limited to this. As we're expanding, we're getting more data ingested into the platform. Do the automatic correlation of these data sources and get insights. Once we get that insight, we can share that using collaborative platforms like Slack or Microsoft Teams. Because as we started the company, it was middle of pandemic, everyone was remote, all the operations were happening remote. And that was the biggest pain point that we saw, that how do folks share the information among themselves? So we integrate with Slack and Microsoft Teams, where folks can ask questions in natural language, get the response. Our bot is a part of that channel, and you can do the debugging collaboratively. So the three main pillars of our product is collection of data, correlating the data and getting those right insights, and sharing it with the team. We'll focus more on the correlation part. Nitin will do a demo to show the product, how it works, but these are the key building blocks of the product. And this is kind of one of the examples that we saw in one of the large service provider. Middle of the night, something happens, folks kind of scrambling, what happened? And they figured out, okay, this is one particular dashboards I have to look at. They have like 50 odd dashboards for metrics, 20 odd dashboards for logs, a few more for applications. But as soon as you get to the right dashboards, then folks have to write a right kind of a structured query language or a SQL construct to get the data back. And the folks who are in the front line trying to figure out what's happening, they may not know the exact SQL language to get that insight. So they kind of go back and forth between these multitude of dashboards and try to figure out what's happening. So our primary focus as when we build the product is to provide that curated, contextual, effective answers when someone asks the questions like, what are the top issues? What are the top applications having the issues? What are the top devices having the problem? Which are the top links having issues? Those are the actionable insights that we provide. And because we store this insight for a longer period of time, you can go back and forth. It's like a DVR. You can go in the past, see what happened, what are the things that are correlated, and go back and forth and see what's happening. And one of the key thing that we saw is that when folks come to 8 a.m. in the morning to the office, they have 2,000 events and alerts to look after. Now, what are the top 5 they should focus on? If they go through 2,000 of those alerts and events, the day is over, they haven't fixed the problem. But what are those top things that they should focus on? We primarily focus on providing that insight. So this is an example of various kinds of data sources that we have already ingested. Definitely, this list is not uh, elaborate. There are multiple other things that we can do, but this is a sample of data sources that we can ingest. So you can see on the left, we can ingest metrics, logs, events, alerts, routing informations, all these things that we can ingest. And we can ingest that data in multitude of different protocols. So it's not necessarily that the folks have to adhere to one particular type of protocol to get the data to us. We support multiple different kinds of things. And also, if folks have collected the data in some kind of a data lake, we can take from there. If they have built their in-house Prometheus time series database, we can take from there. If they have Splunk where they store the logs, we can take from there. If certain tools have certain kind of a REST API connector, we can connect to that and get the data. Sure.
For Cisco, it specifically mentions Viptela, I believe.
Yes.
Is that the only Cisco product?
No, we have connected to multiple different switches, the Nexus suite of switches, Viptela. So there are in different customers, we have variety of different things, but this is not a complete list out here.
Okay, so that's Cisco, including Viptela.
Correct, correct. So we have a SD-WAN use case where we are taking the data from their Viptela manager and ingesting that and providing insights.
Okay.
So Cisco is also like, Viptela is the SD-WAN technology, but if you see SNMP, syslog, those all apply to Cisco, right? So the usual stuff, streaming telemetry, SNMP, CLI scraping, all of that is there. In addition to that, the newer technologies like the Viptela acquisition, because SD-WAN is a space that we are in, and a lot of customers have deployed that. That's why we've called out Viptela specifically.
I was thinking in terms of Nexus dashboard, which would be a great integration.
Yeah.
So this is from a data source point of view. In the northbound, we have integrated with multiple different kind of ITSM tools. Yes, Slack and Team is one way of consuming the product, but we have connected to ServiceNow, PagerDuty, enrich the tickets, which is already being filed. So in the northbound, you can connect to a lot of the other ITSM tools. So overall, if you look at the where the product fits in, it fits in between the monitoring layer, existing monitoring tools, existing metric store, and we provide the analysis and then connect to the ITSM tools northbound so that they can take action on it. So that's the layer where we exactly fit in. So I will give you a few examples of the customers that we are already deployed. And this is just a sample set. We are deployed in large service provider, small cloud hosting providers also, where we look at their backbone network, their edge network, health of their data center. So we are deployed there. One other big use case that we have come across is retail. For example, let's say you have 2,000 different stores all across the world or all over the country. Now, how do you get the health of that particular store? If a store is down, is the backbone network is functioning bad, or is the underlay network is functioning bad, or is that one particular VRF is bad. So those kind of insights we are deployed in one of a large retailer. The third use case, which is deployed right now, is for streaming TV, IPTV. So for example, if you're streaming live, or even though you're streaming the content like what Netflix and others do, is that from performance point of view, if you see some kind of degradation in the performance, why is it happening? Is it happening because of the head end? Is it happening because of the underlying network? Or is it related to one particular subscriber? Or you see a pattern of issues in particular zip code or in particular city? Those kind of insights we provide for a broadcast and the media network. And finally, there are a couple of use cases that were deployed for financials, where let's say you are having multiple different thousands of transactions coming in, and you see a certain kind of a failure pattern happening. Is it related to the application, or is it related to the underlying network? That kind of insights we provide. And as I said, the target environment that we have deployed, data centers, backbones, we talked about SD-WAN edge use case. And also, if you look at the way the platform is built, it is not very specific that we can only do networking use cases. Yes, based on our background, based on our experience, as a startup, that's our target market that we are going after. But the way the platform is built, it can do application analytics also. But right now, our focus is primarily for this year, focus on the networking use cases. But the Nitin and team, the way they have built the platform, there's nothing specific in that it can only work for networking use cases.
But you think you might want to get into that application space? That's a crowded space.
Yes, for this year.
There in the future.
For this year, our goal is not to go there because we see a very unmet need in the networking use case and service provider. We want to focus there as a go-to-market point of view. But from the way the platform is built, we are not have anything that's saying only we can do for networking use cases.
Okay. It's an interesting tease. All right.
Yeah. Just a comment on the application space. APM, as it's traditionally understood, is mostly about how the application is working, right? Like if I have an application which is, say, serving email, right? Like, yes, maybe this part of the stack is not working well. Most APM tools are focused on just the pure application. However, these days, the applications don't exist in silos. An application is probably connecting to the network somewhere. It's connecting to a database that goes across a network. So the application connectivity space, that's what we're going after.
Where I was thinking this would be an interesting fit. Kubernetes, microservices, open telemetry, and correlating all that data so I could ask with a natural language question, what's broken in the Kubernetes stack, and then getting an answer.
Absolutely.
That would be amazing.
Absolutely. Yeah. Because if you look at a Kubernetes network, if you go like squint hard enough, it looks like a BGP service provider network. It's just like entities are different. The constructs are different, but the layering, like you have an IGP, you have an BGP session, all of those constructs have been reinvented in the context of Kubernetes networking at different level, but the constructs and the hierarchy remain the same.
So from a value point of view, what definitely the things folks talk about, yes, we will do an anomaly detection. We look at do the pattern matching. We figure out what's happening. But one key thing that from a networking architect and engineer's point of view, what came across is MTTI, mean time to innocence, because most of the time, everything goes down. The first thing they say that, okay, the network is not working. But when the users are told, they can say that, no, network is healthy. So the mean time to innocence kind of resonates very well with the folks that we are working with in the networking space. Finally, I want to talk about how we deploy our platform. So it's a completely Docker-based container architecture, and it is completely Kubernetes orchestrated. So now that helps us to deploy in a public cloud. We can deliver our service as a SaaS, or it can be deployed on-prem on a customer site, or it can be deployed in a customer VPC if they provide us the compute and the resource. Because the big insight we got during the initial phase of the company is that a majority of the folks do not want to send their metrics, logs, and events to a public cloud. So so the way the architecture is built, we are agnostic to that. If they provide compute and storage on-prem, definitely we can deploy there or we can deliver from the public cloud. So we maintain the complete life cycle of the product, starting from installation, connecting to the data sources. Our customers have to just build some of the dashboards and use very simple construct to do that. They don't have to deal with the different types of data models and the data sources. We take care of that completely end to end.
All those deployment models are available today.
Right now, we are actually, yes, all the 4 that is written here are deployed right
So you do offer a SaaS as well as all
Yes,
those deployment
yes,
models
yes,
that are
yes.
okay.
And it's a function of where our customers are in their transition to the cloud.
Sure.
Right? 20 years ago or 15 years ago, everybody is on-prem data centers. That's what they are comfortable with. That's what their company policies are. The organization is set like that. Certain companies have evolved and they're completely on cloud. And then there is a middle ground where they've evolved to cloud, but it's their own cloud. Right? So they're not comfortable sending data to our cloud. It's their cloud. Like, for example, we are a GCP native. We host ourselves in GCP. But other customers are also in GCP, but that's their project.
Yeah.
Right?
Yeah.
So that's another version. And then there is a hybrid version that they say, we want something done on premises, something done off premises. And for us, we were lucky to be born in an era where the container wars were won by Kubernetes, right? So we were very happy to adopt Kubernetes as our underlying substrate. Once we made that decision, because 5 years ago, that decision wasn't clear, right? We made the decision that, hey, Kubernetes is the ultimate winner. We're going to build a stack on that. Now that Kubernetes is there, we either use Google Kubernetes Engine, their managed service. There are on-prem Kubernetes services that we partner with, Rancher Labs and all that. We just use that. From our development point of view, every deployment looks identical. So for me and my team, as the engineering cost is the same. So yes, it looks, different architectures. It might seem that, your engineering costs are very high because of this. No, it's helped us to go after any customer. And in our current customer list, we have examples of each one of these deployments.
Excellent. And just I'm thinking about the data and specifically around like cloud deployments or SaaS deployments. There's a lot of data. I'm assuming that this data is primarily push, meaning coming from all of those tools into you as a push model. Or do you pull data?
It's a combination.
It's a combination.
It's a combination.
Because I can see challenges around pulling data from a cloud instance down to
Yes.
and there's going to be some
Absolutely.
And do you guys have like you mentioned a hybrid approach?
Yes.
Do you have like a proxy type device that will sit on-prem?
Yes.
To collect data from a pull method, and then that will push it up to a cloud?
And we do have that. In my session, I'm going to describe why that was necessary for reasons like this.
I'll stop jumping the gun.
No, that's fine. Thank you.
One quick follow-up question on the public cloud SaaS offering. Are you in all regions right now, so you can satisfy data sovereignty, GDPR concerns?
No, we're not.
Okay.
But our goal is to get deployed in Europe as well, because Europe is very stringent about GDPR and all that. We're not there yet because our current European customers are all on premises, right? And once they decide to move to cloud model, we would deploy in Europe as well.
Okay, thank you.
So, and finally, one of the business decisions that we made based on the pricing model is based on the number of entities and number of devices or something which is very measurable. The pricing is based on that. The reason is a lot of the other tools, if you see in the market, they are based on the amount of data you ingest. The more data you ingest, the price goes up. And a lot of times the procurement guys are completely surprised why it went up. So it means someone is using the product and they have to pay a lot more higher. So we made a conscious decision saying that the pricing should be such a way that it is predictable. And you can, yes, if you're growing from 10 devices to 10,000 devices, it's understandable. But for the same number of devices, if someone is using our product more and they're ingesting more data, will not charge more. So therefore, it is based on primarily the number of monitored devices. And the reason we are able to do that, because we store insights. We are not storing the raw logs in our platform. That helps to scale the platform, get the faster insight, and you don't have to have two copies of the same thing, one, let's say, in your data store, once again in our platform. That's the architecture and also a big differentiator that we see in the market, because folks complain about this all the time, that they get a price surprise.
I imagine there's some trade-offs and challenges there about how long you
Yes.
store data. If you're
Yes.
looking for insights over time
Yes.
and correlating something that happened weeks or months ago, or maybe something that's, an intermittent challenge. How do you guys approach that?
It's a compromise, right? So first, two things about we don't store raw data, just insights. It's a scale. We do store raw data for some amount of time, but we don't store it for infinite amount of time.
Yeah.
Because we realize that there are other systems of record like Splunk, because we have not primarily an audit tool, right? You want to store data because you want to go back in time and somebody's suing you and you have to say, look, everything is good. Our use case is not that. Our use case is day-to-day operations. So we don't have to store things for years, right? So that's why our costs don't reflect that. Now, even on insights, we do store insights for a reasonable amount of time. 6 months of insights is roughly equivalent to 2 weeks of data, because the insights are so compressed. They have the right signals. You can binary compress all of that. So insights can be stored for almost 6 months. And you typically, and we haven't seen any cases where you want to go debug a problem which happened 6 months ago and start correlating the insights.
I'm thinking more weeks than months.
Right.
Yeah, so it happens every few days. It takes a few weeks to identify what's going on. You want some level of history there. Yeah.
Right. We are deployed in a bunch of service providers and outages happen, right? And you can imagine in a service provider, when an outage happens, there's a lot of postmortem that goes on after the fact, right? Yes, the outage happened, they fix it, and then they move on. But at some point, the bosses get together and say, hey, it's not a blame game, but it's like, okay, what can we do better next time around? So they use us. They say, okay, let's go to Selector AI. Let's look at what the system reported back a week ago when the outage happened. They are able to produce reports out of that, and then they can analyze that. So it's weeks, maybe, not, and maybe a month, but hardly beyond that.
Okay.
Yeah. And finally, as you say, it is not tied to the number of users using the platform. We don't want to do that. A lot of the platforms do that, but that's we want folks to adopt and start using it, so not tied to the user data.
Agents placed on the switches and devices that you're monitoring?
Agents.
So
yes, we have our synthetic agents, which you can deploy on a server or on a switch, which create synthetic data and you get the network health, but that is not required. In many cases, we have seen customers have put their own agents and they push the data to a Kafka message bus and we pick it from there. So we can go both ways. So we have our own agent, but if the customers have deployed their own agents, that's also good for us.
And the vendors, like networking vendors, do get a bad rep for not innovating and all of that. I think they've done a great job in the last few years in pushing telemetry data out of the systems, right? So we don't have to install agents most of the time. There is a lot of support that comes out of every networking vendor. And we are able to get data real time through streaming telemetry or their SNMP plugins. So you can think of SNMP as an agent that the vendor has already installed. It exists. The agent that Deba is talking about is sometimes you want synthetic measurements, like what is the latency from point X to point Y. And networking teams generally don't have access to servers. They don't control the servers. They control all the switches and the networking gear in a data center. So they say, hey, to install a probe, it's hard for me to allocate a server because that's outside my administrative domain. Can you install your agents on the switches? And we do that, right? So our agents it's like a ping agent, which like Thousand Eyes kind of stuff, which measures latency, loss, and jitter, et cetera. So those agents can be deployed on the switches, Arista, Cisco, Nexus, all of that. Those agents get deployed.
Are you using any type of ML and training to determine what the normal baseline is?
Yes,
so you can eliminate
that's what we will come
positives?
to that.
You mentioned telemetry from like networking devices. You guys are using like GNMI or gRPC or those types of tools. And are you, like obviously you need to set up what you send because you're not going to send every ounce of data from GNMI or whatever like that. Are you providing guidance to people on like what they should be pulling, or are you determining what's getting pulled from the device? Like there's kind of a template or whatever.
Right. And this is where my background at Juniper came in handy. That I know that a Juniper device has 1 million statistics that can be pulled. And it is not, the challenge is not in exporting that. The challenge is into curating what is it that you want, what is it that you not want. And our deep background in networking helps us there. So even though the platform is agnostic of the kind of data coming in, we know that, hey, if you from a Juniper or a Cisco device, these are the 10 metrics. These are the most important metrics, we need to pull that. That's why our domain knowledge comes into play. That's why we want to attack new use cases gradually, because we want to understand about the domain. So we do have a sophisticated mechanism of picking and choosing that I want this, I don't want that.
That's a great answer, because it can be overwhelming if you're as a customer trying to figure out what you need to send.
Right.
And you absorb that indirectly. So you'll take GNMI or something indirectly in your product. You don't need a middle ground necessarily for that. Because you mentioned I can send something to a Kafka bus and you can pull off of it, but you don't need that. No, you can send that telemetry right to your system.
Yeah. So GNMI, I've seen with my experience with customers, the deployment is not, the adoption of GNMI is not as pervasive as the writers of GNMI anticipated a few years ago.
Sure.
Right? So it's like 10% GNMI, 90% SNMP. And I feel that that 90% is never, ever going to go down to zero.
Oh, it'll never be zero. No, right. I really wish SNMP would go away, but it's not.
I can't see that happening.
So just to follow up and clarify on that, my own understanding here. So you're being selective in what data you're taking from a particular source, as close to source as possible, or you're taking everything and then essentially dropping what you don't need when it hits your platform.
Combination.
Okay.
Yeah.
So I was saying, if it's the former, where you're being selective, or you're asking a customer to apply a template or select a certain configuration, then that could become operationally burdensome if you decide in the future, well, we need some additional metrics, and now it's on the customer to reapply something to a device.
That is one part, because doing things on the source, on the device, has a lot of administrative burden on the customer. That's one reason. The second reason is some of the advanced customers, they actually have a Kafka bus deployed. So there is a bus that their infrastructure they've already deployed, and their devices are just pushing into Kafka. So they don't even give us connection to the devices. They just give us a connection to the bus, and we suck things into the bus. Now, we are dependent on how they've set up the topics on the bus, right? That there's only so much selectivity we can do, that I'm going to subscribe to this topic, I'm going to subscribe to this topic. Some customers are just learning how Kafka works, and then put everything into one topic.
Which would you say is more common for what you're seeing for your customers now, where you're using the actual end devices as the source, or they're streaming to somewhere else and you're pulling from like a Kafka?
So Kafka has been getting adopted, right? I wish I could say it is going to be the case. The issue is the software skills that our customers have, because Kafka deployment takes a lot of effort. And there is Kafka Cloud offered by Confluent, where it offers Kafka as a service. However, for certain customers, cloud is not an option, right? So they are this, okay, I know operating Kafka is hard on my own. I cannot go to the Kafka Cloud. So then they deploy Kafka, and then we connect up to Kafka. And then when they start trusting us, right? Because we are a startup, and when we started, they were like, yeah, you guys are good, we know you, but we don't know you that well. So we worked with them for a year now, and now they say, hey, you guys are doing well. Can we just skip Kafka? Can you just directly go to our devices? They're more confident in our abilities. We were always confident. It's just them, right? So, and you can connect to the devices. We'll get you certified and all of that. So I don't know where where it's going to end. Maybe a lot of customers will give us connection to the devices, or they will upskill and they will deploy Kafka. But one thing is for certain, Kafka is the distribution mechanism. Like there are so many buses, just like Kubernetes won the containers war. Kafka is going to be with us for some time.